Hello, pre-calculus students. We're talking now about conic sections. Conic sections has to do with how a pair of cones that are inverted, that's one is turned on top of the other, how they could be cut. The word section means to cut, like in the word dissect or bisect or cross section. All of those mean the same thing, that we're cutting through something. In this case, a pair of cones that are connected at the points. And anyway, there's four different things that we're going to look at. There are actually other things we could talk about because there is a point where they intersect, and it could be cut there. You could also slice along the edges and get a line or even an X. But in this case, we're going to look at the four objects you see in front of us. The first one that the book talks about is parabolas. That's this red one here. This is a parabola right here. Crazy. This is a parabola right here. And then you've also got the yellow section, which is called a hyperbola. And then you've got, in addition to that, you've got the circle, which is right here. And that's the one we're going to talk about today. We're also going to be talking eventually about ellipses and hyperbolas and parabolas, but today we're only going to talk about circles. So circles, there's two forms of an equation. One is the kind you see here that are written 1, 2, 3, 4. Those are all in what's known as general form. General form moves everything over and simplifies the terms as much as possible. It also groups them in quadratic and then linear and then constant terms. But the form that's the most useful for us is the one that quickly tells us what the center and the radius are. In this case, the center is the HA, which you can see clearly in the formula here. And the radius is R, also in the formula. So you can see that the center is indicated by these two numbers and that the radius is indicated by this number. Well, in this form, it's not real clear what that is. So we need to rewrite this form algebraically in a way that makes sense and allows us to quickly find out what the radius and the center are. Okay, so we're going to start with this equation, which is x squared plus y squared minus 10x plus 2y plus 17 equals 0. And I don't like that 17 here, so we're going to rewrite it on the other side of the equal sign by subtracting it from both sides. And then over here, it makes more sense to group the x terms together and leave a little space so that we can complete the square. And then the y terms, which is y squared plus 2y. Now, to complete the square, it needs to be a perfect trinomial square, which means we're going to have to add some numbers in here to make those complete squares. I like to work with the next line immediately, since I know that's going to tell me what I have to add in here. I'm going to take that b term and divide it by 2, and that gives me negative 5. Now, right now, this part of this is not equal to this 3 part here because it's missing that the constant there. And that would be negative 5 squared, which is 25. Now, if I'm going to add it to this side, I also have to add it to this side. Same thing is true for the y part, and there's a plus there, so y plus half of 2 is 1 squared. And now I have to add that 1 to both sides to get something that looks like that. And now I can add those terms together, and negative 17 plus 25 is 8, plus 1 is 9. Now that works out for us because 9 is a perfect square. So now I'm in standard form. I started in this form, which isn't standard form, it's what's known as general form, and now we ended up in standard form. And now I can quickly tell what the center and the radius is. The center in this case, I got to get my pen working here. The center is, come on, computer, work with me. The center is 5, 5, negative 1. and the radius is the square root of 9, which is 3. Get rid of that and that. That's kind of messy. All right. So that's how we complete the square. And there are other ones that get a little messier, especially when these numbers happen to start off with something that's not pretty to begin with. Like, notice both of those are even numbers, and this came out to be a perfect square. 9 doesn't always come out to be perfect, so sometimes you have to write the answers as radicals. Likewise, now I can graph this if I have to, because I've got the center and the radius. And so I can get a piece of paper, graph that point, and since the radius is 3, it's easy to count up, down, to the right, and to the left 3, and that gives me an idea what that graph is going to look like. Okay, so let's say we have a new question. Find the equation of a circle with center at 5, -1, and tangent to the y-axis. Well, this sounds like we're talking about a graph. So why don't we look at a graph? Specifically, I like looking at Desmos. Desmos gives us an idea of what's going on here. And Desmos shows anything we want it to. So I graphed the point right there, 5, 1. That's the center. We know that the circle is going to be centered there, but have a radius that goes all the way to the y-axis over here, which that means that I can pretty much figure out what the equation is, except that I might get the center wrong. So the equation is going to be x minus 5 quantity squared plus y minus 1 squared equals r squared. It's going to give me an equation that looks like that. Let me put it on projector mode so it shows up a little clearer. The problem is that that's probably the wrong radius because it's not getting close enough to the y-axis. I need it to be larger. Can you tell what size the radius is going to be if it's going to touch the y-axis from there? That's what tangent means. It's going to touch it in one point. Let's see. That's a radius of 4. It looks like the radius will be 5. Of course it's going to be 5 because if the center is at 5, 1, that means it's 5 units away from the y-axis, which tells me that the equation is going to look like this. Let me pause this. So the equation is going to look like this. Now that I've figured out what the radius, the standard form of an equation of a circle is x minus h squared plus y minus k squared equals r squared. So now we're just going to plug in 5 and -1 into there, which is x minus 5 quantity squared plus y minus a -1 is plus 1 squared equals, we said that the radius is 5, so 5 squared is 25. So there's our standard form of the equation. Okay, let's say we have a new equation now. This one has to do with, we got to get a little trickier here because they get to be too easy otherwise. Find the equation of a circle with a diameter with endpoints 5, 3, and -1, -5. Now, if you think about a circle with a diameter, and I'm just going to try to draw one. It's going to be freehand. It's not going to look very good, but we'll get an idea of it. So, circle has its center, and a diameter has to go through the center like that, which means that each of these sides is a radius, which we have to know those two things. Actually, there's 3 things we have to know. If we know what the endpoints of the diameter are, that center is halfway in between those two endpoints. That sound like a formula we might use? And likewise, we need to know the radius, so the radius is going to be half of whatever the diameter is. If only we knew how to find the distance between 2 points. We do know how to find the distance between 2 points. So the 2 things that we really need to know are the center, which is HK. We can find that by using the midpoint formula. And then we also need to know the length of the radius. And to find the length of the radius, we simply need to know what the length of the diameter is. To find the length of the diameter, we're going to use the distance formula, which is d is equal to, and this is going to look a little bit like a circle, the square root of the quantity x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Basically, we take the difference in the x's, the differences in the y's, square those two differences, add them together, and take their square root, and that gives us the length of the diameter. Once I know the length of the diameter, if I cut it in half, I get the radius. Once again, this is starting to sound a lot like a graph that I could draw. So here I've drawn in Desmos, I've drawn our 2 points. Our 2 points are 5, 3, and negative 1, negative 5. Now I know that the radius is going to be half the distance between those. I also know that the midpoint is going to be halfway in between those 2 points, somewhere right in here. I'm not sure exactly, but somewhere right in there, right? And so the first job is to find the midpoint between those 2 points. So let's go do that real quick. Let me get go to a new page here. And so we're going to do the midpoint between those 2 points. Those 2 points were 5, 3, and negative 5, negative 1, negative 5. 5, 3, negative 1, negative 5. So the midpoint formula says that you add up the x's, 5 by 2, and you add up the y's, divide by 2. And that'll tell you where the midpoint is, which in this case is the center of the circle. So I'm going to take 5 and add negative 1, divide it by 2. I'll take 3 and add negative 5 and divide that by 2. 5 plus negative 1 is 4, divided by 2 is 2. 3 plus negative 5 is negative 2, divided by 2 is negative 1. So my center should be at 2, negative 1. Let's go back to the graph and see if that works. Let's see if that works. That looks like the center of that circle. So now that I know that the center is, I just got to find the radius. Finding the radius is going to require that I know how far apart the diameter is, how far off the diameter is from the circle. Okay, so you can see we have the circle here, but we got the radius wrong because it's not going where it's supposed to. So we're going to have to play around with it until we get the radius the way we want it to. And I'm not sure how to do that right now other than to say that we got to find the distance between 5, 3 and negative 5, negative 1. So let's go back and do that little calculation. Go back to OneNote. And now we're using those same points, but we want to use the distance formula now. So the distance formula is going to take the square root of the difference in the x's, which is 5 minus negative 1, square that. Take the difference in the y's, which is 3 minus negative 5, and square that. And once we do that, we'll add them and take the square root. 5 minus negative 1 is 6, so I'm going to get 6 squared, plus 3 minus negative 5 is going to be 8, so it's 8 squared. I already know the answer to this. It's the square root of 36 plus 64. 36 plus 64 is 100. Square root of 100 is 10. So that tells me my diameter is 10. But the radius is half of that. So I've got to divide it by 2. So the radius is 5. Well, I sure like the radius of 5 today for some reason. But that now tells me what my radius needs to be. My radius needs to be 5. So if I can just make that 5, we're good. So earlier I had the radius drawn wrong. I could tell it was wrong because it didn't hit the 2 points. But now I'm going to get the radius right. It's supposed to be 5. And if you'll notice, it hits all those points. We got center at 2, negative 1. And we've gone through that diameter, which is a line segment drawn from negative 1, negative 5 through 5, 3. Okay, so I'm really literally drawing a line segment from here to there, just like that. And this thing tends to not draw it exactly, but it did go through the center. It'd be better if this point were actually where it's supposed to be, but it's not letting me draw that. So that gives you the idea. And we got our equation. Wonderful. So the one thing I forgot to do is to write the equation. So let me do that real quick. The equation is, come on, OneNote, work with me here. X minus 2, that's where our center was at 2, negative 1, and our radius was 5. So x minus 2 squared plus y plus 1 squared equals 25. And that works.